thank you for attending. It's an honor for me to be here again. I was here 6 years ago, quite some time. After Corona, after everything, I'm back. Today we're going to talk about many things, about open source, about machine learning, about why it's broken, how we can fix it, and also about AI. You're wondering who am I guess. That's me. I work in Munich. I have an events agency and I have a software agency. It's the same thing. So I'm kind of close to what guys from incremental community are doing here. My agency is small. We are just 10 people. We do all things of all variety of things with software development. Mainly it's backends and cloud, a bit of DevOps. We recently introduced also integration of machine learning into our clients' projects, and we encountered like tons of interesting things and experiences, which I'm gonna share with you today. So this is, of course, exactly how we look like at work. As an introduction, let's just think about our cyberpunk AI future that Hollywood imagines in the movies. Like in the best case, AI will just take our jobs. In the worst case, Terminator, we know things can go other ways too. Yet somehow, I'm thinking of my vacuum cleaner, my Roomba. Every morning, like if I occasionally drop my socks on the floor, it kills the AI. So Roomba is incapable of going through the maze of my socks in the room. So this is how I stop robot invasion in my life. I don't think that in the industry things are going much better, to be honest. I mean, of course, we are joking here because this is like household items, vacuum cleaners. Yet, also in the professional software development, everybody's speaking about AI and about ML, but maybe like 1% of people actually understands what they're talking about. Others are just trying to be inside this hype. And the things there are broken, in my opinion. The process of integrating ML into our end-user applications is way too complicated. Why I'm talking about it also is because I'm also doing a PhD. And in my normal work life, integrating ML into clients' projects feels more like a PhD than like normal software development. And that's not how it should be. Now, what I want to do today is first, let's go on a journey of AI. Let's think about how it's working right now, what's wrong there, how it should be working, and let's imagine the solutions that I brought with me. It's about using more of a database and less of pipelines for integrating ML into the user applications. And we will have a little demo of just one of possible solutions that I see in our industry. So we need to step back and look on AI from an unbiased perspective. So before AI can actually replace humans, there is a great deal of work to be done. And the first problem is a lack of skilled professionals. As an agency, this is, I assure you, if you drop an ad on a job board, ML expert needed, no way a small agency can find that guy. Google can, we cannot. And it's not just because of our specific business, it's just because there are not many of them. Usually to be good in AI and ML, you need some sort of, a bit of academic background. It's not just because they teach this at the universities only, of course not, but it's because of the patience and concentration you need to actually understand these concepts. A great deal of mathematics there. This is not how old school software developers work. We find something on Stack Overflow, we copy paste, and it works. No, for this thing to be working, you have to actually understand it. So not many people can do that these days, unfortunately. Also, they are expensive. So most of businesses would be not able to afford like a team of AI engineers. So they ask regular developers to read some blogs and integrate it. And this is how it currently works in the industry. But I just think it's way too complicated for the simple tasks that we want to get out of AI. Then there are also data-related challenges. And this is, first of all, a lack of available data. There's also data security policies not letting us getting this data. And also the time-consuming implementation of ML algorithms. So companies, also big companies and small companies, they have trouble creating an environment to embrace the data and get all the benefits that it brings. This environment, it requires like relevant tools, processes, strategies. Companies know that they need to put all the data somewhere for the later analysis. So they just dump it in CSVs or in some Parquet format on a hard drive on some server somewhere, and they call it a data lake. It's not a database, it's a data lake, because it's not really a database. You cannot query it that easy without Hive or Athena or something like that. So it's a bunch of data laying somewhere, and the companies hope that they can do something useful with it, but for that they need skilled people which they don't have. So that's the next problem. What about automatic tools, you might ask me? What about AutoML? You know AutoML? Heard of AutoML? AutoML, yeah, it's like the machine learning tools that simplifying some steps in building ML pipelines. They are reducing the complexity of machine learning, but I'll show you like in 5 slides or so what exactly is AutoML, where it stands. It's really good. We need to automate everything that we can to do proper integration of ML into our end user applications. But AutoML is just one step there. Then finally, we need to think on this journey about the outcome, what we want to get from these integrations. Do we want to get something like high products, ChatGPT? Probably not. We want some simple predictions. We have a data with the prices. We want in our database somewhere, and we want to predict what will be the price of Bitcoin, stocks, rental, anything 1 year from now. This is like 80% of ML tasks are predictions, in my opinion, and clusterizations. We have a set of images, we want to categorize them. We have a list of texts, we need to run a sentiment analysis on it. These are simple tasks, these are not research tasks. The tools are out there already. We can use API of a third party, like a software as a service, to do these jobs. But the problem is that there is usually one company that does one job well. One company will give a really good sentiment analysis. One company will help you make predictions, and another one will do the image recognition. It's also exhausting to integrate all of them. So sometimes like, big companies decide, okay, we need this AI ML department in-house, and it does everything, and then it's really a PhD thing. You have to research it from scratch. So to prove my words, I'll show you a typical process, how it is done right now. So, and this is where AutoML stands. This is what can we simplify at this very moment. So first, we need to do, let's see, data provider. So data is somewhere here. We need to get the data. We need to label and clean the data. We need some ETL pipelines to prepare the data for analysis. Then there is a feature engineering. We need to build, train, and optimize the model. We need the verification. We need the deployment. We need, of course, the monitoring. We need, of course, the refinement and improvement. We need the optimization of results. We need to reformulate the problem that we had, why we actually started doing this whole thing. And then when we reformulate it, we do the cycle again. To make it less confusing, let's look like this. Our data is somewhere in the database or data lake, call it as you like it. Then we have the application that actually needs predictions out of this data. What we need to do is to build the pipeline somewhere here to do that all cleaning, processing, preparing the data, go somewhere. And then we need to do all of the ML stuff, model creation, evaluation, tuning, deployment, integration, maintenance. And AutoML will simplify this, but not this. And the stupid thing of it is that then the application takes data from here, the predictions, and the past data from here. In both cases, it just takes the data. But somehow, if it's in the future, it has to go from here. If it's in the past, it has to go from here. This is the first. This is like the first case when some people thought this is not optimal. Also, integrating with applications is really difficult because think of the interfaces. If you pull it from the database, it's usually SQL. If you pull it from the ML platform, it's usually API. So you need to implement both. Training is whole another story. If you want to do training of your models yourself, you really need some degree, I think. You can take the existing model, that's easier. But even if the company is not tech savvy, like any code change requests, it has to go through some specific reviews and then need testing workflows, need to involve multiple stakeholders to evaluate the thing. And it all impacts negatively the flexibility. And adds complexity to this whole process, which is complex enough already. So this is exhausting, but it's not just exhausting, it's also strange. Why this thing is done so many times, why it is still so complicated. Today we're not having one good solution, silver bullet. We have ideas. We have some products out there that simplify it. Small companies, big companies that are focused exactly on this, make machine learning more accessible, make it more user-friendly or developer-friendly if you want it. So I'm presenting you just one of the possible ways that is there. And that is about using more of a database for doing your machine learning routines. Why database? So as I say, you're doing this whole, let's go back to this thing. You're doing this whole cycle from the database to the application, back to the database, back to the application. And this takes a while. So one of the ideas is that if we bring this as much closer to this, we will save some time, we will save some complexity. But how exactly can we do this? I'll show you, I have a nice slide here. Embedding AutoML within the database. If we add an AI layer into the database that could pull the data from the database itself, do all the training job inside the database and communicate to the application as if it was a database, we cut out a lot of annoying things in this process. This is not my idea. I was on PyDay Odessa like 4 years ago, and there was one guy, his name was Jorge. He is from Latin America. He is CEO of MindsDB, and back then they were just getting started. So his idea was exactly this. We take most popular databases and we make a wrapper around them. So when the user sends SQL to the database, it actually is not reaching the database, it reaches their wrapper first, MindsDB platform. They added huge database support. This is all the databases which you can integrate with MindsDB. He was very passionate back then about this idea. It was on the initial stage, as I say. He said, like, this is democratization of machine learning. You do not need to write anything if you don't want to. You can have your prediction with a simple SQL, selects, and then if the date goes in the future, it doesn't go to the database, it goes to the model and does the predictions on demand, so to say. It was a good idea, and I asked how you gonna support all of this, and they said it's open source. It's power of the open source to make it publicly accessible, free open source software, and that is true. It is right now open source. I think that some money from VC also helped in developing this, but yeah, it worked, and I like it. So I'm not working for MindsDB, but I was witnessing all this process, how they saw the problem and then developed something and went against the mainstream, so to say, in ML and AI. And where they got right now is incredible. So the magic there is what they called AI tables. So again, they're hiding everything, all their backend as much as possible behind simple database entities, which we are used to. We know what is a table. So they do not want to call it a machine learning prediction model. They call it AI table. It's like a table, but it's AI table, something like a materialized view in a way normal DBA would understand it. So the concept of AI tables, it enables us to perform ML processes within the database. They are available as open source for all these databases that I showed you, and they integrate traditional SQL as well as NoSQL databases and also data streams like Kafka or Redis streams as well. The concept of AI tables is simple. We are creating it with demo. I'll show you in a sec. So we are creating it with normal SQL statements. So we say create table, and then we say create a predictor, and that will create us an AI table. And I will just show you right now a simple demo. So I will be showing you the web version. This is stored in the cloud, in MindsDB cloud. I also run it on my machine. As I say, it's open source. It's really easy. You can run it in Docker. You can pull something like Postgres or MySQL and experiment with this thing freely. But I will show you simple part first. So it's also enough just to go to mindsdb.com and register for your free account. And this is like a sandbox playground, which is good enough to show what can they do. So again, looks like simple SQL. Show databases. Okay, so it's empty. This is just schema databases internals of MindsDB. Now I will post you the syntax, create database, example data with engine Postgres. Here, obviously, I will make it bigger so that you see it better. So MindsDB is a wrapper. So it needs this. It needs credentials to access the actual database behind it. So this is how we make them work together. We tell MindsDB connect to, so correct would be connect database because database exists, right? That's how it looks like. So we run this thing. Okay, database created. So in this example, we are using their standard data set with home rental prices somewhere in California. I will run this simple select, and because this table exists in Postgres that runs somewhere behind it, it does no AI magic. It just goes to Postgres and fetches these, and that's what you get. So this is a sample data set, as I say. It has a number of rooms the apartment has. Peak, of course, because it's the US location, and the price somewhere. Yeah, and the rental price. This is a good example because on this markets, predictions means a lot. Sometimes there are things difficult to consider if we want to predict how will some neighborhood develop over the years, if it has good public transportation connection, if the crime rate is low. So it's hard for a human to do this whole thing, but it's perfect for ML. Good. So now let's do some predictions finally. As I said, we need to create a predictor, and this is how we do it. Create model. We take example data, this table is a source. So we say select star. We could also say just select some of the columns, of course. But everything we're going to select here is a base for predictions of this model we are creating. And then we need to specify the column that we want to be predicting. Say predict rental price. So it really does look like SQL with a lot of magic in the background. It already exists because I created it before the demo, because it takes time to create predictions. So I'll just show you results. So this is like internals. This is the name of the predictor. This is the ML engine that it's using, Lightwood. I think it's an engine that they developed. It's active. Prediction is complete. As I say, it takes time, obviously, so I don't want you to be waiting. The accuracy, pretty high. I wouldn't be so bold about this, to be honest, but yeah. This is a column that is predicted. Yeah. And the query, what we used for predictions. Now, finally, I want to have some results. So if we are in process of generating the predictions, then the status here will be generation or something like this. so we can build our applications reliably, so that we only get we fetch predictions only when this thing is complete. Okay. Now, it's a bit hard to jump between these two monitors. So this is what we are running a predictions. We are predicting here what would be the rental price of 1,000 square feet house with 2 bathrooms. The bathrooms are 2 square feet, 1,000. And this is a prediction of how much it would be. This is another example for you. This is how to make batch predictions. So you see that we are using SQL joins here to predict multiple things at a time, so that we don't need to do it one by one. I'll scroll down so you see better. So we have different predictions for different inputs, and we are using another table which is joined here as a criteria for predictions. Then, of course, yeah. Yes, right. I just needed 2 hands here. So, good. Yes, sure. One more thing I want to show you in the SQL editor is this. Moment. Is how to automate these workflows partially. Most of developers hate database triggers and stored procedures. So of course they implemented that as well. So this is kind of a stored procedure. Automation technique, create job. So this is to do this every 2 days. Because you want your predictions to be fresh, you want to pull the new data from the data source that you have, and this is the easiest way to keep predictions fresh. Now let's go a bit more in details. So I will talk more about why I think that this is a good approach and what are they developing right now. And this is just one of the many ways to simplify machine learning for normal application developers. It integrates not only with databases, it also integrates with many APIs and with many data streams, as I said, like Kafka or Redis. They also have implemented, because it's open source and their community is pretty active and they do invest in their community. So if you join their Slack channel, they are discussing what integrations will be developed next. Something like they know the hype of OpenAI and ChatGPT, so they developed right away a way to integrate ChatGPT into here. So basically you just say, okay, we are using a ChatGPT OpenAI connector. You specify your API key, you specify just the API key. And if you have one column would be a question and another column would be the answer. So this is how it can do. You write a predictor, which is not really a predictor. It goes to the OpenAI. It's running this question for running one query for every question you have in your database and puts answers in another column. So for you, it still feels like a database, but it's not. It's a batch job of thousands of requests to OpenAI. But for you, it still feels like you are querying your database that is already there. Then main thing, which I did not mention yet, why I am using this is not because I'm lazy to do it the proper way. It's because my clients usually don't need the proper way. My clients just need these numbers at the end. And this is easy. And this is what their developers can maintain after I'm done with my job. Everybody knows SQL. It's really easy to read. It's easy to understand. And it's easy to integrate with the BI tools that they have. Power BI, MicroStrategy. All of these things are operated usually by people who have very low clue about software development. They are data analysts, they are business analysts, and they know SQL usually. For them, it's really easy this way to put forecasting in game. So they can query not only the data that is already available, but also the data that would potentially be available in the future this way, because it's just SQL. I think that this is the main part, and this is a killer feature. As I say, we can learn another API, it just takes us time. We can integrate complicated pipeline, it just takes us time. But BI tools cannot. I mean, it's just so much overhead if we need to integrate Power BI with some external data source, with some weird API endpoints in some old exotic, I don't know, FTP push, for instance, is the most exotic thing I've ever seen. Some data providers give you FTP server and then push files there, and then you need to read these files. That's how they send you the data. Things like this, impossible to integrate with modern BI tools. Good. Now let's jump back to the presentation. I think that's pretty much it. So I want to catch up with time. I don't want to screw the schedule further. It was screwed already. So I would rather focus on the questions now, and maybe if you have something specific, we can focus more on that. So I think that's it with the demo, and let's continue with questions. Yes.
Thanks. Yeah, so can you also like boost like certain parameters? Like if you do machine learning, you boost on certain things you find more important probably, right?
Absolutely, yes.
How would that work? How would you, if it's needs configuration probably?
Yes, of course. So you can configure most of the things in this standard SQL-like fashion. They are not developing this pipelines and the tools. They're only developing the wrapper around it. So everything that is inside can be configured, as well as the whole model can be swapped. Let's say you just want SQL interface, but you have your model trained already by your team. You just swap it. So the compatibility is really good. Like MLflow, from what I remember, models are easy to be swapped. Basically, most of the tools that are inside can be swapped. It's just you usually don't want it. And they can be also configured. It's just that usually you start like this, and then you see, this was a good example. When I was playing with the sample data sets, I often get something like 1.5 bathrooms in my predictions. Yeah, so you do need to tweak it.
Yeah, like stuff like neighborhoods and
absolutely,
kind of things, right?
Yes. But it's, of course, it is configurable. This is just a way to lower the entry barrier, but that when you're there, you use the same interface to change the parameters of it.
Oh, cool.
Okay, more? No more. Very good. So I guess we have time for our coffee. You don't. All right, thank you very much.